Let us look at proposition number 15 of works of Archimedes, specifically from on conoids and spheroids. The proposition is actually, there are two parts to it. So let's take it one by one. The first part says, if from any point on the surface of a conoid, a line be drawn, in the case of paraboloid, a parallel to the axis, and in the case of the hyperboloid, parallel to any line passing to the vertex of the enveloping cone. The part of the straight line which is in the same direction as the convexity of the surface will fall without it, and the part which is in the other direction within it. This is basically a pretty straightforward proposition, the part of the proposition. So let's look at it. Given a conoid with its axis. So let's say we have this conoid and we have this axis. And this is the vertex. Now, remember this paraboloid and the hyperboloid. The one similarity is that that is made up of two inverted paraboloid. Yes. So whatever is applicable here would also be applicable there. Now take a point P on the surface of the conoid. Draw a line through P parallel to the axis of the conoid. Draw a plane through the axis and the point P. So we have to draw a plane which is going to be through P and through this axis. Okay, so this plane is passing through P and it is passing through the axis. The intersection between the conoid and the plane is a conic. If it was a hyperboloid, it would have been a hyperbola, the intersection between this plane and this hyperboloid. But in case of paraboloid, it would be a parabola. Part of the axis of the conic is outside the conic. So now we are basically not looking at the paraboloid itself. We are just focusing on this conic. So a part of this axis is outside the conic and a part of it is inside. So towards the convexity, it is outside. And towards the concavity, it is inside. The line through P is parallel to the axis of the conic. Because now remember, this axis is the axis of the conic as well as the paraboloid. So this line passing through P is parallel to this axis of the conic. And the part of the line through P, which is in the same direction as the convexity of the conic, is outside. And the other part is inside the conic, which basically means that the same thing applies to the conoid, that is a paraboloid. Similarly for the hyperboloid as well. So that was the first part of the proposition. Now let's look at the second. Now the proposition says, if a plane touch a conoid without cutting it, it will touch it at one point only. And the plane drawn through the point of contact and the axis of the conoid will be at right angles to the plane which touches it. So again, here also there are two parts. So take it one by one. So given a conoid with its axis, take a point P on the surface of the conoid. Let the tangent plane touch the conoid at 2 points D and E. So first let's draw the plane through P. That is a tangent plane through P. And let's say it is not cutting it at 1 point. Let's say it is cutting at 2 points. That is D and E. Draw through DE lines parallel to the axis. Now the plane passing through both parallel lines will pass through the axis or be parallel to the axis. So again, let's draw the plane passing through both the parallel lines. Now the intersection of the plane with the conoid will be a conic. Now this purple plane will cut this paraboloid in a conic. Points D and E lie on this conic. So D is on this conic and E is on the conic. The line segment DE will lie in the conic. So let's draw a line passing through D and E. Yes. And if you will notice that this line is inside the conic. The line segment DE lies on the tangent plane. That is what we have started off with. And some portion of the tangent plane will be inside the conic. That means, say, DE lies inside the conic and DE lies on the tangent plane. That means some portion of the tangent plane will be inside the conoid, which is an impossibility since the plane is not supposed to be cutting it. If a plane touch a conoid without cutting it, it will touch it at one point only. So even though we have assumed that D and that it is touching it at 2 points, it is still not supposed to cut it, but it is ending up cutting it. So which means the plane touches the conoid at 1 point only. So that was this part of the proposition. Now let's look at the next part. The plane drawn through the point of contact and the axis of the conoid will be at right angles to the plane which touches it. So again, let's take a point P and let this P be the point of contact of the conoid and the tangent plane. Draw the plane passing through the axis and the point P. The plane cuts the conoid in a conic whose axis is the axis of the conoid. So this orange plane will cut this conoid in a conic, and the axis of this parabola is the same as the axis of the paraboloid. Now the tangent plane intersects with the plane through the axis in a line DPE touching the conic at P. So the tangent plane intersects with this plane. So these two planes intersect each other. Yes, in a straight line. Let's mark these points so that we can refer to them. So axis in a line DPE touching the conic at P. Now draw P and P prime perpendicular to the axis and intersecting it at N. So let's draw a line perpendicular to the axis so that it touches the opposite side of the conic at P prime and it intersects the axis at N. Now draw a plane through P and P prime perpendicular to AN. Yes. So here this green plane is a plane through P and P prime and perpendicular to the axis. Now this plane will intersect the conoid in a circle and meet the tangent plane in a tangent to the circle. This green plane is intersecting the conoid in a circle and it meets the tangent plane in a tangent to the circle. This plane will be perpendicular to PN. So this green plane is perpendicular to PN. The tangent to the circle will be perpendicular to the plane containing PN and AN. So the tangent to the circle, this tangent is also the tangent of this circle. So tangent to the circle will be perpendicular to the plane containing PN and AN. And which is the plane which is containing PN and AN? PN and AN, they'll both lie on this orange plane. So the plane containing AN and PN is perpendicular to the tangent plane. So that was proposition number 15 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now. Bye.